In this video, we detail 9 major challenges facing wastewater works in Japan, and their solutions. The first challenge is flood control in urban areas. These photographs show recent typical damage caused by urban flooding. Underground facilities such as subway stations and underground shopping malls are easily damaged by floods. Due to the increase in extreme weather events and in urban concentration, the magnitude of flood damage is rising. Comprehensive measures are being pursued to ease the situation. These measures are a combination of structural, non-structural, and self-help measures. Structural measures include the improvement of storm sewers and the construction of storage and infiltration facilities. Non-structural measures include real-time flood forecasts and flood maps for citizens. These measures work well with self-help measures and include voluntary evacuation and sandbagging by citizens around private properties. The second challenge is the need to increase earthquake resilience, because Japan is prone to strong earthquakes. Once wastewater systems are damaged, the impact can be severe. For example, a damaged sewer system can cause a spillage of wastewater that runs into residential areas and public water bodies. This would pose a serious threat to public health and sanitation. In addition, broken sewer lines make flush toilets unusable, which has a severe impact on the health of survivors. Liquefaction is a common phenomenon after an earthquake. This results in manholes protruding through road surfaces, which results in severe disruption to traffic. As a result, emergency vehicles are affected immediately after an earthquake. For these reasons, wastewater systems need to be earthquake-proof. Central government is implementing 2 measures to achieve this. First, it is providing subsidies to wastewater utilities to fund earthquake-proofing work. Second, it is suggesting that each utility formulate a Business Continuity Plan (BCP). A BCP is designed to ensure quick restoration of essential functions of wastewater services. The third challenge is the implementation of asset management. A total of 460,000 kilometers of sewer lines and 2,200 treatment plants have been built. This massive amount of assets continues to age. The failure of aged facilities will pose a serious problem soon, if left unaddressed. It is reported that around 4,000 sinkholes are caused by failed sewers every year. These photographs show examples in downtown Tokyo. To remedy this situation, the following 3 points are emphasized. The first is preventive maintenance. The second is a condition assessment. The third is renovation based on long-term planning. In relation to preventive maintenance, in 2015, the sewerage law was amended to ensure proper sewer management. The fourth challenge is eutrophication in stagnant coastal and freshwater bodies. The water quality in public waters has steadily improved in rivers and running water. But there remains the problem of eutrophication in stagnant water. Pollution has been observed in bays of Tokyo, Nagoya, and Osaka. Lake Biwa and Lake Kasumagura, Japan's 2 biggest freshwater lakes, are also eutrophicated. These pictures shows the consequences of eutrophication: red tides, blue tides, and water bloom. These phenomena severely impact fisheries, ecosystems, and scenic beauty. To help counter eutrophication, nutrient removal is necessary at treatment plants. But the implementation is slow, particularly in the watershed of Tokyo Bay. To expedite the solution, central government has recommended 2 measures. First, the phased introduction of nutrient removal processes. Second, joint action with concerned offices. This slide shows an example of phased introduction of a nitrogen removal process. It makes minor modifications to an existing conventional activated sludge system. As a tentative treatment method, it utilizes the extra capacity of existing facilities with minor upgrades. The second solution is cooperation with related government offices. Alleviating eutrophication needs to involve not only wastewater operators, but the authorities of other dischargers at point and non-point sources. In particular, for the control of non-point sources, the involvement of government agriculture and forestry offices is essential. The fifth challenge is restoring waterfronts. Over the decades, waterfronts in urban areas have diminished. The main reason for this is the loss or reduction of running water due to urbanization. Decreasing pervious areas, conversion of urban streams into culverts, and climate change in recent years are responsible for this. To revive waterfronts, 3 solutions are implemented to increase the flow of streams. First, the use of treated wastewater. Second, rainwater utilization after storage, and infiltration. Third, revival and creation of waterfronts with civic participation. Partnerships with citizens from planning to operation and maintenance produce good results. The sixth challenge is the improvement of combined sewer systems. A CSS is designed to convey sanitary wastewater and storm water in the same pipeline. This results in an overflow of untreated wastewater when a system receives heavy rainfall. CSSs have been used as a low-cost solution in urban areas, and serve approximately 25% of the population. But CSSs need improvement for the protection of public health and for a clean water environment. In 2001, fat, oil and grease balls (fog ball) drifted ashore at Odaiba Marine Park, attracting public attention. As the park is a very popular leisure spot in Tokyo, it was revealed by the media that the fog balls came from a CSS, which resulted in a major social controversy. Since then, serious efforts have been made to improve CSSs all over the country. The improvement of CSSs has 3 policy goals. First, reduction of pollutant load. The total pollutant load from a combined sewer system shall be equal to or less than a separate sewer system for the same sewer district. Second, public health protection. The number of overflow events of untreated wastewater shall be cut by half. Third, elimination of gross solid discharge. Gross solids shall not be released into public waters from CSSs. In 2003, the sewerage law was amended to make policy goals mandatory by specified deadlines. The deadline for small and mid-sized municipalities was set as 2013, and for large municipalities it was set as 2023. To date, 169 out of 170 small and mid-sized municipalities have completed their requirements. 2 out of 21 large municipalities have also completed improvements. The 7th challenge is an expansion of service. Currently, there are still around 14 million people waiting for access to wastewater treatment services. In these areas, untreated grey water is discharged directly into the environment. It is an urgent task to deliver wastewater services to these areas. To expedite the expansion of wastewater services, 3 solutions are ongoing. The first is the implementation of a low-cost solution, named the Quick Project, being applied intensively. The second is a study of new procurement methods, such as private finance initiatives (PFI) for the construction and management of sewer systems. The third is a revision of local master plan for wastewater services. The services switch to on-site systems from the originally planned centralized systems into populated areas. The 8th challenge is the enhancement of the living environment using wastewater assets. Examples include Use of flood control ponds as recreational waterfronts. Utilization of the space above treatment plants as playgrounds. Use of wastewater facilities for disposal of collected snow. Installation of optical fiber cables in sewer lines. The photographs show a playground constructed on a treatment facility in Tokyo. In total, 369 treatment plants have opened the spaces above them for public use in Japan. The last, but by no means the least, challenge is the transformation of wastewater services into recycling services. The focus is shifting from the traditional public health and water environment to recycling. Wastewater systems collect resources through sewer networks. Then they generate clean water, energy, fertilizer, phosphorus and construction materials. This slide shows examples of sludge recycling, as a construction material and as a transportation fuel. Wastewater works in Japan are striving to deliver the best service possible to customers while facing these 9 challenges. We will continue to work for a sustainable society through wastewater service. Thank you for watching this video, presented by the Japan Sewage Works Association.